Hey guys, I'm back. Now we're going to talk about rules for graphing inequalities. So I believe this is on page 11 in your journals. Turn to graphing inequalities and your notes should be there. The first thing I want to do is talk about what is an inequality. You know, so many times we go through and we know the process, but what does it really mean? An inequality is just that. It's not equal. So no longer can we use the equality symbol when we talk about an inequality. Because if I asked you, x is greater than 5, what does that really tell me? What number can x be? Can x be 5? It can't be 5. It's got to be greater than 5. So that means it can be 6, it can be 7, it can be 5.5, it can be 8, 9. It's any number that's greater than 5. So when we graph it, if this is my target number, and I call this guy my target number, when we set up a number line, I want 2 integers to the left, 4, 3, and 2 integers to the right. That's how we set up our number line. And if we graphed it, it's an open circle on 5, because what that tells the reader, when you have an open circle, it tells the reader that 5 is not a part of this inequality. But if x is greater than 5, it's any number greater than 5. So it can be like 5.111 or 5.5 or 5 3/4, and any number greater than 5. Something I want you to do a quick check when you do this. We've been training to keep our variable on the left-hand side, right? Yes, absolutely, we keep our variable on the left-hand side. When you look at this as graphing form and this form right here, you will notice that this arrow is going to follow this arrow. So if x is greater than 5, it's going to follow, my greater than sign is going to be this arrow going to the right. Okay? So that's what inequality means. It can't be equal because it's not just one number. It can be many, many hundreds, thousands, millions of numbers. So that's real quick on what inequality means. Now let's talk about how to graph them and what are like the little simple things that we use to tell the reader what my inequality stands for. So here's what we're going to do. We are going to use an open circle for greater than or less than, just like we did over here on that example, because open circle does not include the target number. It includes either greater than that target number or less than that target number. We use a closed circle for greater than or equal to and less than and equal to. So if I look at number 1, it's saying x is less than 3. So what are some numbers that represent values less than 3? Well, 2 is less than 3, 0 is less than 3, negative integers are less than 3. So here's what I'm going to do. Does this include 3, my target number? No, it's less than 3. So it's open circle on 3, and I shade to the left. When you do your inequalities, I'm really, really picky, so this is what I need. I need you to do the open circle on the number line, and your shaded line needs to be bold and proud and go through on that number line, okay? So that's the correct way to graph that inequality. Number 2, x is greater than -1. Does it include -1? No, so it's open circle. Notice my arrow is going to the right, so my shaded arrow is going to go to the right, because numbers that are greater than -1 are all these positive integers. Number 3, x is greater than or equal to 7. So can my target number be 7? Absolutely. So that means that if it is 7, I'm going to close in that circle, because that's telling the reader 7 is definitely part of that range, and anything greater than 7. If I look over here, x is less than or equal to -5. Can x be -5? It absolutely can. So I'm going to circle -5, and then I'm shading all the way left. Notice when my variable is on the left-hand side, these arrows match the direction of my line, okay? So that's how we graph them. That's what the open circle versus closed circle means. And now let's write an inequality for the graph given. So we went from an inequality to graphing it. Now let's go from graphing it to writing my inequality. So the first thing I do is you can use any variable to represent the number. So I'm going to use x, and then I'm going to write down my target number. My target number here is -2. It's open circle, so it means it can't be -2, I'm going to go with my arrow to the left. So what this is saying is x is less than negative 2. So again, let's look at that. The variable's x, always on the left-hand side. My target number is negative 2, and it matches the direction of my arrow. It's open circle, so it means it's less than negative 2, not equal to negative 2. Okay, jump over to number 6. My variable x, target number 4, it's closed circle, my arrow goes to the right, so it's greater than or equal to. It can be 4. Number 7, x, my target number is 0, closed circle, so it's less than or equal to. And number 8, my variable x, my target number is negative 3. It's open circle, so x is greater than negative 3, and notice my arrows are matching the direction of my line. All right, now, here are when we solve for inequalities. So this is just graphing from an inequality to a graph and from a graph to an inequality. But now when we solve for inequalities, there's a rule that you need to use, and I don't know if you remember it, but you must flip the inequality symbol when you multiply or divide by a negative coefficient. So that means if your variable term is negative, notice my vocabulary here, variable term. If my variable term is negative, you gotta flip the sign somewhere along that line. So I can, just real quick, look at number 9 and see, is my variable term positive? Yeah, no need to flip here. Look at number 10, is my variable term positive? Yeah, no need to flip. Look at number 11, my variable term is negative. Somewhere along the way, I'm gonna flip a sign. Look at number 12, my variable term negative. I'm gonna flip a sign. 13 is negative, I'm gonna flip a sign. 14 is negative, I'm gonna flip a sign. 15 is positive, I'm not gonna flip a sign. 16, negative 5, 6, I'm gonna flip a sign. So I want you to see when you would and when you wouldn't. It's when that variable term is negative that you gotta flip your sign. All right, so now let's do some practice problems. Number 9, I already know I'm not gonna have to flip because my variable term is positive. So I'm going to go through the process just like we do on 1- and 2-step equations. It's using that additive inverse. It's using that multiplicative inverse. So I'm going to subtract 2 on both sides. 3x is less than negative 6. Divide both sides by 3, and x is less than negative 2. Remember, that's my inequality, but I'm also asking you to graph it. So we start with my target number in the middle, negative 2, and then we're going to fill out 2 integers. Well, actually, here it leaves me with 3 integers. 3 integers to the left, 3 integers to the right. It's open circle on negative 2 and shade to the left. Thank you, Jen. All right, number 10. I'm going to subtract 2 on both sides. X over 6 is greater than negative 3. Multiply both sides by 6. X is greater than negative 18. And again, I'm going to fill out my number line. Negative 17, negative 16, negative 15. Open circle on 18 and shade to the right. Now, let's do some ones where we flip. So I am going to do, all those are flipping. All right, so let's do 11. So number 11, I'm going to subtract 8 on both sides. Here I get negative 7x is less than or equal to negative 7. Now remember my rule. If I multiply or divide by a negative, I gotta flip my sign. So here I'm going to divide both sides by a negative. When you divide, a light bulb should go off. Flip your sign, flip your sign, flip your sign. So x is now greater than or equal to 1. So when I divide both sides by a negative, I flip that sign. I fill out my target number line, close circle on 1, shade to the right. So I'm going to do a few more of these practice problems, and then you can check your work against mine to see if you're doing it the right way. So let's do, I'll do 17 through 20, okay? So 17 through 20. So I'm going to add 2 on both sides. 5x is less than or equal to negative 5. Divide by 5. X is less than or equal to negative 1. No need to flip the sign because my variable term is positive. Here's negative 1. So it's closed circle on negative 1, shade to the left. Number 18, I'm going to subtract 6 on both sides. I get negative x is less than or equal to 8. Now I'm going to divide both sides by a negative 1. Light bulb bulbs going off. Divide both sides by -1, so x is greater than or equal to -8. So -8 is my target number. I'm filling out my number line. Close circle on -8, shade to the right. Number 19, I'm going to subtract both sides by 4. And look, I get -1/3 x is greater than 7. I'm going to multiply both sides by a -3. I'm multiplying both sides by a negative. That flashlight should go off, and I'm left with x is less than -21. I had to flip my sign. Target number is 21, so I'm filling out my number line. 19, -18. Open circle on 21, shade to the left. Number 20, this is one of those special cases where I got to clear out my fraction first. And notice, am I multiplying both sides by a negative? I am. So if I'm multiplying both sides by a negative here, I'm going to flip my sign. And I'm left with x plus 11 is greater than +4. And now I'm going to subtract 11, and x is greater than 8. 7. What am I thinking? 7. So 7, 8, 9, 10, 6, 5, 4 on my number line. Open circle on 7, shade to the right. So that's what your example should be. If you're lost and you need help, come see me in tutoring.